Welcome to another episode of TASC Mathematics. Today's mini lesson focuses on the product rule for exponents. Now, the product rule states that if you have a base raised to an exponent m and you're multiplying by a matching base raised to an exponent n, so your bases are different or they could be the same, you will keep your base and add your exponents. Let's try some examples. My first example, I have 2 raised to the third power and I'm multiplying by 2 raised to the fourth power. Now the 2 here is our base, and the rule states that when your bases match, you keep your base and we're going to add our exponents. So we're going to add 3 plus 4. So my answer is 2 raised to the 7th power. Now, why is that? Now we have 2 to the third, and 2 to the third means 2 times 2 times 2. And then you're multiplying by 2 to the fourth, which means that the 2 is going to multiply itself 4 times. Now if I count all of these 2's, I get 1, 2, 3, 4, 5, 6, 7. So in the expanded form, I have 7 2's multiplying each other, but I can write it more simple as an exponential, which means a base of 2 raised to the 7th power. The mathematicians realized that you don't have to do this in order to get your answer. They realize that when your bases match, you keep the base and you add the exponent. 3 plus 4 is 7, the same 7 2's we got here. So if we try the second example, I have x to the 5th multiplied by x to the 9th. My bases match. I'm going to keep my base of x and I'm going to add my exponents. 5 plus 9. So my answer, x raised to the 14th power. Now, sometimes you may get an example where you have numbers in front of your variables. These numbers, we call them coefficients. So here I have 3y to the 6th power, and I'm multiplying 7y to the 15th power. Now the coefficients will multiply each other. So the 3 and the 7 will multiply each other. The y to the 6 is going to multiply the y to the 15 because the rule states the base must match. 3 times 7, 21. Now when your bases match, you keep your base and you add your exponents. So I'm going to add 6 plus 15. So my answer is 21 y to the 21st power. 6 plus 15 is 21. Let's try that again. Now, sometimes they might add more than one variable. So here I have x and y's. So I have negative 5, x to the 4th, y. And I'm multiplying by 8, x to the 3rd, y to the 5th. Now remember, the negative 5 and the 8 are your coefficients. So they're going to multiply each other. So the negative 5 is going to multiply the 8. The x to the 4 is going to multiply the x to the 3rd. Because remember, in order to apply the rule, the bases must match. And then I have y, and I'm multiplying that with y to the 5th power. Now negative 5 times 8 will give me a value of negative 40. Now I have x, 4 plus 3, because remember, the bases match. You keep the base, add the exponents, 4 plus 3. And then for the y, I must add my exponents as well. Now if the y is all by itself, there is an exponent there. It's a 1. I'm going to change the color so that you know, so you can see. Let's see, we'll make it red. There is a 1 there. So if the variable looks like it's all by itself, it's actually a 1. So let's close that. Oh, there you go. So that would be 1 plus 5. I actually changed my pen color. That was that one. Yep. 1 plus 5. So my answer is negative 40. X, 4 plus 3 is 7. Y, 1 plus 5 is 6. So the key thing you have to remember here, if you have a variable and it looks like it's all by itself and you don't see an exponent, there is an exponent. It is an invisible 1. So that's 1 plus 5 and we got 6. So our answer is negative 40, x to the 7th, y to the 6th. Now, whenever I teach the laws of exponents, I try to sprinkle in, I'll say the word sprinkle in the negative rule as we go along. So here I have x to the negative 13, and I'm multiplying by x to the 9th power. Now my bases match, so I'm going to keep my base of x, and I'm going to add negative 13 plus 9. Now I notice that when my signs are different, I perform a subtraction. And when I subtract these two numbers, I get 4. But the rule states I must keep the sign of the larger absolute value. So I have negative 4. So here my answer is x to the negative 4 power. Now you cannot have, well, it's not like you cannot. In algebra, we do not like negative exponents. So if you have a negative exponent, you need to write it in the positive form. And that's where the negative rule comes in. The negative rule states, if you have a base of a raised to a negative exponent, to write it in the positive form, it is 1 over a raised to the positive exponent. You're basically writing the reciprocal. So my answer here would be 1 over x, and my exponent is now a positive 4. Let's try another problem. Here I have negative 3, x to the 5th, y to the negative 10, and I'm multiplying 4, x to the negative 2, y to the 6th. So remember, the coefficients will multiply each other. So the negative 3 is going to multiply the 4. Then x to the 5th is going to multiply x to the negative 2. Y to the negative 10 is going to multiply y to the 6th power. Negative 3 times 4, negative 12. Now here my bases match, so I'm going to keep my base. And I'm going to add 5 plus negative 2. And then the y's, I'm adding negative 10 plus 6. So I have negative 12, x. Now remember, when the signs are different, you perform a subtraction, which gives us 3, and keep the sign of the larger absolute value. So that's a positive 3. Then we have y. Again, my signs are different, so I perform a subtraction, which gives me 4. But my larger absolute value is 10, so my answer is negative 4. Now remember, negative exponents are not allowed. We must always write positive exponents. So I'm going to keep the negative 12 because that's not an exponent. That is your coefficient. So the negative 12 stays, the x to the 3rd stays, but the y to the negative 4, I have to write that in the positive form, which will be 1 over y to the positive 4. Now, to make this answer more simplified, what I usually tell my students is draw a fraction bar all the way across. And if you look at it, it looks like in the numerator, it's going to be negative 12 x to the 3rd power, and in the denominator you have y raised to the 4th power. Because technically you are multiplying. You're multiplying the negative 12 with the x to the 3rd times the 1. If If you multiply all of those, you're going to get negative 12x to the third, because the negative 12 and the 1 multiply each other to give you negative 12, and we're just going to keep the x to the third because we can't really multiply it, so we just kind of like stick them together. And the denominator is just y to the fourth. Let's try another example. We have 2a to the negative 6, b to the negative 7, and I'm multiplying 4a to the negative 2, b to the third power. So as before, the coefficients, the 2 and the 4, will multiply each other. A to the negative 6 is going to multiply a to the negative 2. B to the negative 7 is going to multiply b to the third. 2 times 4 is 8. My bases match for the a, so I'm going to keep my base, and I'm going to add my exponents. So I'm adding negative 6 plus negative 2. And then for my b's, I'm going to be adding negative 7 plus 3. So I get 8a. Now remember, when the signs are the same, you add, so 6 plus 2 is 8, and you keep the sign. So that's a negative 8 as your exponent. And then b, now my signs are different, so I subtract, which would give me 4. And I keep the sign of the larger absolute value, so I get a negative 4. But remember, negative exponents are not allowed. So I get 8. When I rewrite the 8 to the negative 8th power, I get 1 over a to the positive 8. And the b, which is raised to the negative 4 power, rewritten in the positive form, is 1 over b to the positive 4. Remember, when you write in the positive form, the negative exponent goes away. Now we want this to look a little bit much nicer, more simplified. So again, I'm going to draw just one fraction bar. And remember, all of this is a multiplication. So 8 times 1 is 8. And then here, in the denominator position, you're going to have a to the 8th power and b raised to the 4th power. And this is how we utilize the negative rule. So as I go through these rules for the laws of exponents, I'll always try to sprinkle in the negative, because this is where I find students have most difficulties. I always tell my students that whenever your answer is negative, that is when you're going to convert it to a positive exponent by writing the reciprocal. I hope these examples have been helpful. Good luck in your examination.